Hey students, today's lesson is on independent and dependent events. So let's start with some key ideas. Compound events can be either independent or dependent. If events are independent, one event does not affect the likelihood that the other event will occur. They're independent from each other. So, as we're calculating the probability of two independent events, we find the probability of each of the two events, or three events if there's more than two, and then we multiply those probabilities. We find the product. So let's practice with that. If we want to find the probability of spinning this spinner and getting a prime number and flipping tails, we first have to think, is this independent? Yes. Spinning the spinner is not going to impact the coin flip in any way. They're totally independent. So we're going to find the probability of each of those independent events. So let's first find the probability of spinning a prime number. We have 5 numbers to choose from, and the prime numbers would be 2, 3, and 5. So there's 3 numbers out of 5 that are prime. So our probability would be 3 out of 5. Then we can find the probability of flipping tails. And we know that with a coin flip, there's 2 possibilities, and one of those 2 possibilities is tails. So now, to find the probability of both A and B, we need to multiply 3/5 times 1/2, which is 3/10, or 30%. So there's a 30% chance that we're both going to get a prime number and flip tails. Those are independent events. Now, let's look at dependent events. If events are dependent, the occurrence of one event does affect the likelihood that the other event will occur. It will somehow factor into that probability. So let's look at an example of that. Well, we'll look at the formula first here. So, same idea, we're going to multiply the probabilities, but we have to keep in mind that for the second probability, it's the probability of B occurring after A occurs. So we have to keep that in mind. So here we have an example where we're at a game show. There are people randomly chosen to be contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first, and then one of your friends is chosen second? Okay, so let's find the probability of your relative being chosen. Well, you have 5 relatives in the audience out of 100 total people in the audience. So we can simplify that to, there's a 1 out of 20 chance that one of your relatives is going to get chosen on the first try. Then we're going to look at the probability of one of your friends getting chosen. So one of your relatives has already been chosen, but you still have all 6 of your friends. So there are 6 possibilities of your friend getting chosen, of one of your friends being chosen, but now there aren't 100 people in the audience. Now there's only 99 because it's the second time around. So there's a 6 out of 99 or 2 out of 33 chance that your friend is going to get chosen, or one of your friends will be chosen. So now if we want to find the probability of both event A and event B occurring, we need to multiply these probabilities. So 1 out of 20 times 2 out of 33. Let's simplify before we multiply here. 2 goes into itself once and into 20 10 times. So our probability would be 1 out of 330, which is about 0.3%. So not very likely that things are going to happen in exactly that order. All right, now, let's look at our third example here. Here we have, you're taking a test, and unfortunately, you're just randomly guessing the answers. So that is not a good situation to be in. We've got 3 multiple choice questions. We want to know what's the probability of answering all 3 questions correctly. So we need to think first, is this independent or dependent? I would say independent, right? whether you get number 2 right has no bearing on whether you got number 1 right. You're going to have a 1 in 5 chance every time of choosing the correct answer because there were 5 possible answers. So this is going to be an independent event. And when we want to find our probability, it'll be 1/5. There's a 1 in 5 chance of getting the first one right. There's a 1 in 5 chance of getting the second problem right. And there's a 1 in 5 chance of getting the third problem right. So that would be 1 over 125, which is about 0.8%. So you have less than 1% chance of getting all of those correct if you're just randomly guessing. All right, so that was method 1. Sorry, I put that in the wrong place here. So method 1 is going to be 1/5 times 1/5 times 1/5 is 1 over 125, or 0.8%. Now, the other thing we can do is use the fundamental counting principle. So we can say there's 5 choices for number 1. There's 5 possible outcomes. There's 5 possible outcomes for number 2. And there's 5 possible outcomes for number 3. So that's 125 possible outcomes. And only one of those outcomes is going to be that you got all 3 correct, right? That you chose the right answer on all 3 problems. So that's 1 over 125, or 0.8%. All right, that is it. Go ahead and try a few on your own. I'll see you soon.